Deep beneath your brain lies a tiny gland, smaller than a pea, yet it commands nearly every hormone in your body. It is none other than the pituitary gland, the master gland of the endocrine system. So today, we'll learn about the pituitary gland, its location, structure, functions and secretions. The pituitary gland, also called hypophysis cerebri, is an ovoid structure weighing about 0.5 gm. It hangs just below the hypothalamus, connected through a slender stalk called the infundibulum. It sits inside a protective bony cavity of the skull, the sella turcica of the sphenoid bone. The hypothalamus and pituitary are deeply connected, like a control room and its operator, forming the hypothalamic pituitary axis, which maintains internal balance or homeostasis. Now, let's learn about its lobes and their secretions. So, basically the pituitary gland has three lobes: anterior lobe, median lobe and the posterior lobe. Let's dive into them one by one. We'll zoom into the anterior lobe first. The anterior lobe is actually the one referred to as the master gland, because, in addition to the primary hormones, it also produces the tropic hormones, which control the secretion of hormones in many other endocrine glands. The anterior lobe, also known as adenohypophysis, secretes the following hormones. Number 1. Somatotropin hormone. First, hypothalamus secretes a protein, the somatotropin-releasing factor, SRF, which then goes to the anterior lobe of pituitary gland and then, it secretes somatotropin. Somatotropin is a growth hormone, and is secreted throughout the life. When growth has mostly ceased after adolescence, the hormone continues to promote protein synthesis throughout the body. So we can say that somatotropin is a growth hormone. However, if STH is not produced in a balanced way, it can cause the following disorders. If produced in excess during early life, it can cause gigantism. If produced in low amount during early life, it can cause dwarfism. And if produced in excess later in life, then it can cause acromegaly. Acromegaly is the abnormal development of hands, feet, jaws and other body parts. Number 2 is the thyroid-stimulating hormone. The hypothalamus secretes a protein called thyrotropin-releasing factor, which then goes to the anterior lobe of the pituitary gland and it secretes thyroid-stimulating hormone. It acts directly on the cells of thyroid gland and increases its secretory activity. The release of TRF from hypothalamus is controlled by the levels of thyroxine in the blood. In the presence of low levels of thyroxine, there is increasing production of thyroid-stimulating hormone, and vice versa. It is secreted throughout the life but particularly reaches high levels during the age of growth and development. Third ones are the gonadotrophic hormones. Gonado come from the word gonads, which means sex organs. Receiving commands from the hypothalamus, the anterior lobe of pituitary gland secretes the following hormones. 1. Follicle-stimulating hormone. 2. Luteinizing hormone in females and interstitial cell-stimulating hormone in males. 3. Prolactin. It is inappropriately called as the luteotrophic hormone, because it performs the same function as luteinizing hormone in rodents. It is worth noting that follicle-stimulating hormone and luteinizing as well as interstitial cell-stimulating hormone share a common hypothalamic releasing factor, whereas prolactin is continuously produced from the pituitary gland. Let's discuss them one by one. Follicle-stimulating hormone. In females, it stimulates development of ovarian follicles. It also stimulates secretion of estrogen from the ovaries. In males, it stimulates development of germinal epithelium in testes. It also promotes sperm production, spermatogenesis. Luteinizing hormone or interstitial cell-stimulating hormone. The LH works in females while ICSH in males. It works with FSH to stimulate estrogen secretion, cause ovulation, rupture of mature follicle and release of the ovum. It stimulates luteinization of the ruptured follicle, forming the corpus luteum. It also acts with prolactin to maintain the corpus luteum, which keeps secreting progesterone. The ICSH works in males. It stimulates the interstitial cells of testis for the secretion of testosterone. Then comes the prolactin hormone. It stimulates milk production in mammary glands. And because it is continuously secreted, it is inhibited by prolactin inhibiting hormone from the hypothalamus. It also acts synergistically with LH to help maintain the corpus luteum. Another hormone secreted by the anterior lobe is adrenocorticotropic hormone. The same story starts from hypothalamus. It then secretes a protein called the corticotrophic releasing factor, which then goes to the pituitary gland. It then secretes the adrenocorticotrophic hormone, which acts on the adrenal glands to secrete cortisol and thus helps in stress managing. The release of CRF is controlled by steroid levels in blood and by direct nervous stimulation as a result of stress like cold, heat, pain, fear, and infection. Now, let's look into the median lobe. The median lobe secretes only one hormone called melanophore stimulating hormone. It stimulates melanocytes in skin to produce a brown pigment called melanin, which darkens the skin. Its secretion is governed by external light and its inhibition is controlled by hypothalamus. There is more secretion of MSH during pregnancy and in Addison's disease. And finally, the posterior lobe. Well, the posterior lobe does not secrete any hormone of its own. In fact, it secretes the hormones that are produced by hypothalamus and are stored in the posterior lobe of pituitary gland. There are two such hormones. Number 1. Antidiuretic hormone, also known as vasopressin. It regulates water retention in kidneys. Its secretion is caused by low blood pressure, low blood volume, and low osmotic pressure of blood. To maintain balance, it increases water reabsorption in distal parts of nephron. A lack of this hormone produces diabetes insipidus. Number 2 is oxytocin, also known as love hormone. It is stimulated by distension of cervix, parturition, and decreased progesterone level in blood. Its primary action is on the smooth muscles, particularly in uterus during childbirth, and also causes milk ejection from mammary glands. Finally, we conclude our topic with a brief flowchart showing the function of different hormone. Which hormone fascinate you the most? Tell us in the comments section below, and don't forget to like and subscribe.